So let's talk about what this dilemma is. Because with these, I could really solve any layer higher with the floppy iCubes, and it really doesn't add that much more to it. You just do more of your baseline solve, and you end up filling in the gaps. So basically, none of these are going to be filled in, but it's fairly easy to put in. This is going to be in, these two are going to be in, and these three are going to be in. So all you're really getting is you're getting these extra pieces over here that have to be put in. So it doesn't matter how much larger it is, it's only going to be one extra piece, one extra layer on the top layer, and it's always going to be the second layer over here. So notice it didn't really take me that much more. But as we dissect things down to its very core, we end up getting a challenge that we didn't really expect. So the first step with this is we're going to place the first layer. Same kind of thing. And the thing about these edges is these edges don't scramble, they just rotate. So it seems pretty easy just to put them in. So I put them in over here. And then this one doesn't move because these are bandaging it, so I'm just going to put this over here, and now I've got to somehow bring this up. So how am I going to do this? Well, there's no specific strategy, you're just sort of playing with it, but I'm going to move this out of the way, down like so I can move this. So this moves up, and then I can move this down. So now I've got these two here. So I'm not interested in putting these in the proper position yet, just like I did with these. But just like I did with these, I just want to move them all to where they're in the right layer. Then I can start variating it. So what I'm going to do is I'm just going to move both of these down so that I can free up the bottom, move them both in, and curse splat. Okay, so great. We're back to the native shape. How am I going to put these in? These never scramble with each other, but I'm going to take this down and just move it to the below layer here. Orange and blue is going to end up here, so I'm going to move it 2 away, move this down, substitute it in, bring it up, so now we're in. Okay, so this is pretty easy. This has to come up to here, 2 away, bring it down, pop it up, move this out of the way. This needs to come into here. All right, so once we find our way to this, it's not too much of a problem, and curse splat. Okay, now that we have this layer, how are we going to deal with this? Well, we can't coordinate this with any other layer. It doesn't mix with anything. Again, we're kind of done with our 3x3x1 aspect to it. So what we need to do first is work on these edges, and I need to orient the edges. I need to flip these. Well, this is done the same way. Here's a line, and luckily, I'm okay with this algorithm of F, R, U, R, I, U, I, F, I. So these are fine. I can even put them in the right place. This doesn't belong. Well, this belongs here. These don't. Move this into here. This is good. This is good. So hold this to the right and this to the back. And I can even do an RU, RIU, R2U, RI. So I can do that too. Move this into place and we're okay. So the next step that we would do is of course, corners. Now to corners, there's permutation where, well, there's orientation actually, where you flip these to the right orientation, and then there's permutation where you shift them, translate them to the right place. So how do we do that? Well, we can do a permutation algorithm of U, R, U, I, L, I, U, R, I, U, I, L. And then what we would do is move them in the right place, then just do R, I, D, A, R, D to bring them back. Well, here's the problem. I can't do both of those algorithms. Now I can do the one where I slide these around. So which one is in the proper place? This one isn't, this one isn't, this one isn't, and this one isn't. But I can do a U, R, U, I, L, I, U, R, I, U, I, L. So I'm pretty secure in the notion that I can move them to the right place. This is in the right place, the rest aren't. U, R, U, I, L, I, U, R, I, U, I, L. So not yet. Do the same algorithm. No difference with the 3x3. So now these are in the right place. So all I have to do next is RID them into submission. And here's where I run into a problem. I can't. RIDI, oop, I'm gone. And then I start bandaging myself to a point where it's not going to work. So I'm not sure how I got that back, but I can't do that. So what do? How do I get these guys permuted and oriented? How do I do PLL and OLL? the only algorithm that I have available to me is RU, RU, R2U, RI. And all that's going to do is move my edges around. I want to keep the edges where they are. So this is the challenge. I actually have to use the one algorithm, UR, UI, RI, U, LI, UI, or something like that. Either that algorithm, but I actually have to somehow either get a different algorithm to cause rotation, or I've got to do them both at the same time. So that's my question. How am I going to do that? Think about it. Tell me what you think, and I'll come back with the answer. Okay, back again. So what do you think? We had the dilemma over here. Well, the only thing that I can think to do to get out of this situation is to use one algorithm to provide two functions. Literally, two birds with one stone. And that's going to be the same algorithm, U, R, UI, Li, U, Ri, UI, L, to both do the same function and permute and orient at the same time. So we have to somehow coordinate that. Now, this is a time where you have to take the algorithms that you always use, and there's probably some other effects that it had on the puzzle that you just ignored. But at times like this, you have to figure out exactly what it did in every other way that you didn't anticipate. What were the other effects? In other words, the algorithm that caused permutation of the corners, did it also cause a change in orientation? And the answer is, it did. But let's see how it does that. So I've got this over here, and we're going to do that same thing. Let's see what happens with let's see what happens with that algorithm. We know this is not going to change, but let's see what happens as this goes around the puzzle. I know this will come to here, this will go here, and this will go here. So it's going to be UR, UI, Li, URI, UI, L. So you can see they're not all right side up. This is not like a corner swap. Corner swapping would be great if I could do this. But I can't do a corner swap because I don't have another layer to mix it with. But let's take a look at what happened. This came over to here, right? And it flipped. This came over to here and it flipped, and this came over to here and it flipped. So one roll of this algorithm caused them to both permute and flip. It did an orientation issue and a permutation issue. Well, how many times is it going to roll until it rolls right side up? So let's do it again. The first time we did it, it rotated out of sync. I shouldn't say upside down, but it rotated towards not oriented correctly. So let's do it again and see what happens. This will come to here, this will come to here, and this will come to here. Turn, 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 and turn. Okay, now this is over here, but it's still oriented wrong. So basically what happens is that the first time you do the algorithm, it flips. The second time you do the algorithm, it also flips, but it still flips wrong. What happens with the third time? Turn, 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 turn. Now you can predict what's going to happen based on the law of the cubes. It comes back. So that's what I have to keep in mind. That's the process that I have to bear in mind. When I follow a piece out, if I do that algorithm 3 times, it'll come back to the proper orientation. So it has 2 wrong flips before it's flipped right. And that's how I have to bear that in mind. It can move twice before it flips correctly. So I have to somehow figure out a way to coordinate all of that. So let's see. I guess here's what has to happen. The very last move before everything is correct is this has to be in and oriented correctly, and all the rest have to be oriented incorrectly and rotated incorrectly. So that's what has to happen. Now, it would appear that that's the case, except that this is in. This is correctly placed. If I kept sending this around the puzzle, then this would rotate correctly, and then incorrectly and incorrectly. So basically, it'll always end up in this position. So what I'm going to do is I'm going to focus on any one of these other pieces. And I guess ask myself the question, how many more flips does each one have before it's flipped right? So let's try it again. Turn and turn. Okay, so now it's all flipped right. Okay, so this is correct. Incorrect, incorrect, and correct. So I want to send this to here. All right. This gets sent to here now. Okay, now I have to bear something in mind. One more will put this here in the correct position. But before I do that, let's just see what everything else is doing. Okay, these are all about to be correct, and this is going to be incorrect. Okay, so what I have now is a situation where I want to keep this one incorrect. I'm going to hold this here, do the algorithm again. I know these are all going to be incorrect. This is going to be correct. This is going to be held as incorrect. So let's see where the sparks fly with this. Okay, and that's what I predicted. So that's good. I've got it back to the safest of configurations. And the thing is this needs to come into here. It's about to be correct. I don't know, and I can't remember if these are going to be correct or not correct. I suspect not. I don't think this is going to work. And sure enough, it doesn't. It's right back where it came from. Okay, this brings me back in this position here. So all of these are about to turn in a position that isn't going to work. Incorrect, incorrect, correct. Let's try that. I'm going to keep sending this around. Okay, one more. This is about to be correct. I'm going to hold it like this. Okay, this to come into here. And one more will do it. Okay, so now this is in here, and let's see if this is going to work. This is correct. These are all oriented and permuted wrong. Turn, 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 and it worked. Okay, so that's what I mean about how this is a challenge. Now, I didn't want to memorize every confirmation that could possibly be. For me, that's not fun. Instead, I just coordinated it to see if I can get one that's in and three that's out. And it didn't always work, so I had to sort of send it back and forth in order to make that happen. So you saw that there's a lot more hemming and hawing with this. These are pretty straightforward. This one, is, because of the bandaging, is really where the challenge lay, which just goes to show you shouldn't stop collecting. As you see things getting bigger or getting smaller, try it out, because you never know if it does something that's unexpected. And that's what this lesson taught me, that despite the fact that this looked like a smaller version of what turned out to be a much higher order collection that was getting higher in complexity, I had a feeling that there was something about the smaller version of it that was going to be more challenging. So although from time to time I'll do these solves, this is the one that I keep turning to, because this is the one that gives me the biggest challenge towards the end. And I admittedly on purpose do not try to think of every permutation, because it's kind of a fun challenge, a fun little mental exercise to make that happen. So there you have it. That's what all the floppy iCubes have to offer. Other types and variations of floppy iCubes and iCubes Extremes for the future. Until then, we shall return to the cuboids. So, thanks for watching.